Yeah, it was done.
Okay. Dipole.
Yeah, dipole done.
Electric field due to dipole at an axial point, equatorial and torque derivation done.
Yeah, done.
Electric flux, everything is done.
Just let me go through it.
Actually, I have a confusion. Did I teach you electric field lines properties?
Wait. Let me see. No, I guess. Like the line of forces do not intersect uniform electric field or two equal like charges. That all right? Hello? So,
Yes.
I think no.
Okay. Today we will discuss all the derivations.
Okay.
Now try even this question. Now try. You have 5 minutes to go through this question, then we will discuss it. 5 to 10 minutes.
So
Fast.
we have also not done, I think, to find electric field intensity at a point due to charged spherical shell.
Charged spherical shell. Okay. Just a minute. First of all, let me teach you this derivation.
Okay.
Write down here electric field. Electric field. Just a minute. Electric field due to thin spherical shell. Fine. Just a minute, Iram. That would be a spherical shell. It would be small, capital Q. The charge accumulated on its surface. having radius capital R. Now we have to calculate the electric field at 3 points outside on the surface and within the surface. Let it be a point P. Q charge on the surface. R is the radius of the shell. Now to calculate electric field, first R is greater than R, second R equals to R, and third R is less than R. Now let it be. Then what we do? Let it be a Gaussian surface. Let it be a Gaussian surface. Small r. Small r is a variable distance from the center of the shell. Now, so first, when r is greater than r, it means P lies outside the shell. So this is a shell having radius r. What we have to do it? First of all, we have to imagine a Gaussian surface around it having radius small r. Okay, now total charge on it is Q. Again, we have to apply the Gauss theorem. First of all, by first, by definition, flux equals to E times area. What is the area of this? This is a Gaussian surface, okay? Gaussian surface. This is Gaussian
2
surface.
pi r.
4 pi r square
4
because it's pair, okay? Now by Gauss theorem, Gauss theorem equals to Q over epsilon. Now this is first equation. This is second equation. From first, second, over r square. Did you get it?
Yes, sir.
Fine. Likewise, second, when r equals to r, it means when the point P lies on the surface. Again, this is a shell having radius capital R. The point lies P here. So by definition again, phi equals to E into 4 pi r square. Now by definition, phi equals to Q over epsilon. This is Q. This is first. Now from first and second, 4 pi r square Q over epsilon. E equals to r square. All right. And further, we can also write Q over epsilon 4 pi r square. And what is 4 pi r square? Area of the sphere. So we can write sigma over epsilon. So sigma equals to surface over area. Surface charge density. All right, Iram. Is it
Yes, sir.
okay?
Yes, sir.
Okay.
So just can you give me 1 minute? Someone is at my door.
Okay.
Yes, I'm so sorry, sir. Hello, sir.
Okay. Okay. Iram, now the third point is the point lies within the surface when r is smaller than this. Inside the surface. When the point P lies inside the surface. Fine. Now again we have to imagine a Gaussian surface. Gaussian surface. Now, so electric field, again, we have to do the same thing. 4 pi r square equals to, what is the total charge enclosed by the Gaussian surface? Will be 0, because in case of conducting shell, the charge always reside on the surface of the conductor. So charge is 0 over epsilon. So electric field will be equals to 0, because Q inside is 0. All right, Iram. Now graph.
Yeah.
R equals to R, inversely proportional to R square. Fine. Fine. This is the graph. On the surface, the electric field is, this value is 1 over 4 pi Q over R square. Okay. Is it fine, Iram?
Yes, sir.
Now, we should discuss the questions based on electric flux. Now, try this question, Iram. Try this. Try 5 minutes. Then we will discuss fast. Iram done. Look how to do this question. Electric field as a function of, look, variable electric field is given, that is Ex equals to alpha x raised to power 1 by 2. Okay, now electric field along y-axis and z-axis is 0. Alpha is given 800 Newton per coulomb per meter square. Look here. Out. First of all, we have to find out the electric flux through left surface, then right surface. Left surface. And right. So pi L equals to, now, if I ask you what is the direction of the area vector, electric field is along positive x-axis. And if I ask you what is the direction of area vector for the left surface, what is the direction for this surface? Iram, this surface?
Left side.
Left side. So angle will be 180 degree. So
Yeah.
E dot E into area is A square to cos 180. No. So minus EL A square. Is it fine?
Yeah.
What is area? Alpha x by 2. What is A? Okay. Now, first of all, we have to calculate the electric for the left surface. Okay. Before that, this time. EL. EL equals to, what is the distance from the origin? A. Fine. This is EL. Fine. Now, flux phi L equals to EL into area cos 180. That is minus EL A square. Now, substitute the value. Minus alpha A raised to power 5 by 2. Is it fine? Iram? First of all, look, the
Yeah.
electric field is variable. Now, similarly, we have to calculate the electric field for right. What is the distance of x? What is the distance from the origin, the second surface? Root 2 alpha A raised to power 1 by 2. Now, this is the distance of the second phase from the origin. Electric flux. Now, phi R equals to ER. The angle will be 0. Now, this is electric field. Now, total flux. Total flux equals to phi L plus phi R. What is phi L? Now we can take out as common. All right. Now total flux phi equals to Q over epsilon. Fine. What is the flux we calculated? Multiply by epsilon, you get the value. This is the charge. Okay. Did you get it? This is the methodology. This kind of question comes in your exam. Okay, Iram. Shall I repeat the entire process again?
Yes, sir, please.
Look, there are two surfaces. The electric field is variable. X is a variable distance from the origin. So first of all, we have to calculate the electric field for the left surface. Likewise, we will calculate the electric field for the right surface. Then we will calculate the flux. Now, then for the left surface, the area vector will be towards the left, and for the right surface will be towards the right. But the electric field direction is along the positive x-axis. So for if we calculate the electric flux for the left surface, then the angle will be cos 180, that is minus. And for the right surface, the angle will be 0. So just substitute the value electric field this way how to calculate it. Alpha equals to 2a raised to power 1 by 2, root 2 alpha 1 by 2, root 2 alpha a raised to power 1 by 2. Now substitute. Are you okay with the calculations? A raised to power 1 by 2 and a square is.
Yeah.
Now just add them. We can take out alpha a raised to power 5 by 2 as common, root 2 minus 1. Substitute the value of alpha a, you'll get the value. Okay. Now a is 0.1. This kind of calculations you should use calculator, because 0.1 raised to power 5 by 2 we have to calculate. Now once you get the value of the total flux, just equate by the Gauss theorem. Phi equals to q over epsilon, and multiply the flux by permittivity of free space, you'll get the value epsilon naught. If you multiply the flux by epsilon naught, you get the total charge. Okay.
Yeah.
Now try this question. This is an NCERT question. Fast. It is an NCERT question. Fast theorem. 5 minutes. Theorem. Are you getting this question, or shall I make you understand?
No, sir, I'm not.
Okay, look. Okay, an electric field is uniform in a positive x direction. Now electric field is given. Fine. For the positive x axis, the electric field is 200 I cap. For the left means when x is greater than 0 means for the right portion means for this portion, for the right portion, the electric field we have to take it 200 I cap, and for x less than 0 means for the left portion we have to take it electric field as minus 200 I cap. Now fine. So again similarly, now we will calculate the electric field for the right portion. Okay, just the area vector for this, the area vector will be towards right, and for this the area vector again will be towards left. But for the last portion, the direction of the electric field is along left direction. It is given in the question. Okay, it means, Iram, this, what do you mean by this? X is greater than means for the right portion, the electric field is along positive x axis. When x is less than 0, it means the electric field is along left direction. Now again we will calculate the electric flux. What is, okay, if we calculate the electric flux for the right portion, what will be the angle between area vector and electric field? Iram, for this portion, what is the direction?
Towards right.
Towards right. Okay, so a angle will be 0 degree. So 200 into what is the area? Area will be given, land radius is given. What is area? 5 centimeter. First of all, we have to change into meters. So pi into 5 into 10 to the power minus 2. Yeah. Now 200 into 3.14 into 25 into 10 to the power minus 4. Now calculate, just let me know the answer. How much will you get it if you simplify it fast? First, let me know the answer. Just do the calculation fast.
One point five.
1.5. I think 1.57, isn't it?
Yeah, 1.5.
Total tends to our something also. What is the total answer? 1.57 tends to our. You did the entire calculation. Iram.
So
1.
1 minute. No, there's no power.
1.57 tends to, there is no power.
No, the
Okay.
actual answer is
1.
15700 into 10 to the power minus 4, and you take it.
Okay,
So
fine.
that's it.
So the total answer is 1.5 voltmeter. Now, likewise, you'll calculate for the left portion. Now, again, 200 pi. In this also, you'll get the same answer because everything is same. Area, electric field is same, area will be same, and the direction is again cos 0. Because in this case, the electric field is along the left direction as well as the area vector. So phi L equals to 1.57 voltmeter. Now the total flux equals to phi R plus phi L. And what is the net outward flux through the each flat face? Now this is right, this is left. Second, what is the flux through the side of the cylinder? Means through the curved surface. Hiram, this is the curved surface. Okay. Now what is the direction of the area vector for this surface? Curved surface. Electric field is either left direction or right direction, but the area vector will be perpendicular to the curved surface. Then cos 90 and the flux will be 0. Okay, for through this surface, second portion, second flux 0. All right, because the area vector and the electric field both are perpendicular. What is the net outward flux through the cylinder? We have to calculate the total flux. It means third portion is 0 plus 1.57 plus 1.57 and it would be 3.14, I think, voltmeter. Okay.
Okay.
Now, what is the net charge enclosed? How will you calculate the fourth question? We have to use which theorem? Gauss theorem.
Gauss.
So by Gauss theorem, phi total equals to Q over epsilon. So Q equals to epsilon times phi t. Now you 8.854 10 to the power minus 12 into 3.14. Let me know the answer first. Do the calculations first. Cool.
-2.78
2
into
point
10 to the power minus 11.
minus 11 coulomb. Did you get it, this question? Is it okay with it?
Yeah.
Okay,
So,
fine. Did you get it how to attend these kind of question if these kind of question come in your exam?
yeah.
Most important portion of this chapter is electric field, Gauss theorem, electric flux, and dipole. Before doing this question, try this question fast.
The first one is 1 by 3.
Yes, 1 by 3 is correct. Yeah.
So I'm not getting.
Second question you're not getting.
No.
First, the total flux we have to calculate. So phi 1, that is Q over epsilon. Phi 2, equals to Q over 2Q, sorry, 3Q over epsilon. Now the ratio will be 1 over 3. Now second question. How will the electric flux through the sphere S1 change if the medium of dielectric constant K is introduced in this? How will, okay. So the flux phi 1 dash becomes Q over K epsilon. Phi over K epsilon, sorry. The flux becomes phi over K. That is, what is flux? Q over K epsilon. Flux through the first. All right. Now third question. How will the electric flux through the sphere S1 change if a medium of dielectric constant K is introduced in the space inside S2? No change. Because the dielectric is introduced in the in S2. No change. So how will the electric flux through sphere S1 change if the medium of dielectric constant K is introduced in the second medium? If we introduce in the other medium, the flux will not change. All right. Okay.
Yeah.
Now try this question. Okay. Wait a minute, Iram. I have to connect the charger. Just a minute. Done, Iram.
No, sir.
Done.
So I'm not getting this.
Not yet. Now, we are given a charge capital Q at the origin. O. Refer this figure. Consider a sphere S with center 2,0,0 and radius of this is this. Consider the another sphere of radius √2 meter. Another sphere of radius √2 meter. Centered at the origin. Okay. Both have same radius. Now consider the spherical caps PSQ, PSQ, PRQ and PWQ with the normals outward acting along the x-axis. Now what is the sign of the electric flux through each surface? Electric flux. So a capital Q charge is placed at the origin. Now capital Q charge is placed here. All right. Let me see the question. Okay, capital Q charge, consider a sphere S with center 0,0,0 radius this, and consider the another sphere of radius √2 meters centered at the origin. Now consider the spherical caps PSQ, PSQ, PRQ, 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 and PWQ, PWQ with the normals outward to the respectively spheres. What is the sign of electric flux? E surface. Now for the first surface, we have to calculate the sign. So PSQ. What is the direction of the electric field due to this positive charge, Iram? If one of the charge away from means will be here. All right,
Yeah.
will be here. Now, if I consider PSQ, now the area vector for this will be what is the direction of the area vector for this surface?
Perpendicular.
Not perpendicular, left or right? The electric
Left.
field will for this the electric left. Then the angle between electric field and the area vector are opposite, and the electric flux will be negative or positive.
Negative.
Please mute your mic. Fine, negative. For this portion, negative. For PSQ, negative. Now, PRQ, positive. PWQ, again, positive. All right, Iram. That's it. Now, what the flat circle PTQ? PTQ. PTQ. What is the direction? Positive. Now, second position. We have to look at the direction of electric field as well as the area vector. Now, second. Now, what is the relation between the magnitudes of the flux through the surface, first and second? Now, we have to calculate the electric flux. Electric flux means the number of electric field lines. What is the relation? Will be the same or different? First, Iram. Through PSQ, PTQ, PRQ, and PWQ.
Same.
Same in every case. The three PSQ. Please mute your mic. Now first is PSQ, electric field lines, and second PRQ, and third is PWQ. The flux will be same. Just a minute. We have to calculate the number of electric field lines. PTQ, PSQ. Look for PSQ, PTQ, and that is PRQ. That flux will be same for this portion. All right.
Yes, sir.
And for PWQ will be different, I think. All right, will be different because more number of electric field lines will cross this. And third position, and for third position, calculate the flux through the surface second, that is PRQ. PRQ. What we have to do it? We have to imagine a Gaussian surface. All right. Fast, Iram. Now try 5 minutes. Sorry, 2 minutes. What is the total flux? Answer is we have to calculate 4.5 10 to the power -9. Fast, Iram.
Yeah, that's what I.
Okay, how did you do it? Flux is E into A. What is electric field where we have to calculate at a distance? What is your distance at A? Just a minute, let me rub. Is not given. Electric field directly calculate the electric flux through the surface second. Okay. Means PRQ. PRQ. What is the radius, by the way? Radius is, so electric field equals to 1 over 4 epsilon Q over R square. And what is the area? What is the area, Iram? Area of the surface.
4 pi r square.
Sorry, 2 pi
R square.
by R square. 2 pi R square, but why? Basically, the electric flux is number of electric field lines passing perpendicular to the given surface. It means we have to calculate the number of electric field lines. So electric field is, just let me know the answer. Q over